5. Well, this one, you see, what's the problem once again? It's that it doesn't give you a diagram. So what are you going to do? Right? All at once, everybody together, you're going to make a diagram. Okay, calculate the arc length of a sector with area 165.8 that is contained by a central angle of 108. All right, this example, the very end of page 6, this is everything you've learned in these 6 pages, all put together in one little problem. Okay, so let's make a diagram first. I'm going to start with a circle. Good, that looks like that. And I've got a sector with an area of 165.8 and a central angle of 108. So let's make our sector here. It's got a central angle of 108. That's a little bit more than 90. So I know it's probably going to look something like this. Your diagram's not going to be to scale, but it helps to be kind of approximate, right? And then we can, let's use some other color here to make it very hard on the eyes, all right? So this is my sector, and I know that the area of my sector is 165.8 centimeters squared. And I know that in here, my little central angle here is 108 degrees. And it's asking me not for the radius. It's not asking me for the diameter. It's not asking me for the circumference. It's asking for the arc length. Calculate the arc length. All right. Well, this is what we're going to have to do. I know that I've got sector area. I've got the central angle. And with those, I can say to myself, well, which formula is going to be any use to be able to do anything with that? I've got this one up here. Sector over area equals x over 360. And let's see what I can do with that. And if you think back to a few videos ago, the other big formula we were using for all those problems was this one. We knew that arc over circumference is also equal to x over 360. Right. Arc over circumference equals x over 360. Oops, I wanted that line here. Arc over circumference equals x over 360. Now, what that means I can do is whenever I have a proportion like this, and I know 3 of the things, like I always know 360 because it's just 360. If I can plug in the sector area and the angle, then that will give me the total area. And with the total area, I know that if I have the total area, I can get the radius. Now, once I have the radius, that will allow me to get the circumference. And I already know that the central angle up here, the x, is 108. And if I know the circumference and the central angle in 360, I'll be able to get the arc, which is what I'm supposed to be getting. All right. Now that's a lot, but that's just to give you an overview of what we're going to do here. Basic thinking for a lot of these problems, you can say to yourself, what do I know and what am I trying to get to? And if you're not even sure really what you're trying to get to, focus on what you know. Say, well, I've got a sector area and I've got a central angle, and I've got this formula which says, give me sector area, give me central angle, take 360, and you'll be able to find the area. So let's start with that. Okay. We take the spots that are open. Sector area is 165.8. Central angle was 108. The area is what I don't know, and the 360 is just the 360. So I'm plugging in the numbers that I know in the spots that they're supposed to go to. Right? Already, this can become a little clearer. Right? Once I have it set up like this, the main reason why I want to set it up is so that I can calculate the missing part of the proportion, the a here. I can cross multiply. I do a times 108. 360 times 165.8. Or if I want to cut corners a little bit and use that trick which comes in so handy in this unit, I can use the fish method. Right? The fish method just says to get A, you do 165.8 times 360 divided by 108. Let's write that out. A is going to be equal to 165.8 times 360 divided by 108, like that. And then I break open the calculator. 165.8 times 360 divided by 108 gives me the total area of my circle, 552.67. Okay. So the area of the whole circle is 552.67 centimeters squared. Now, once I find the total area, I know, you remember this from back here, I can figure out what the radius is if I just move backwards, right? What's another way of thinking of area? Area, I can replace that with pi times the radius squared. So let me rewrite this. I've just replaced the A here with pi times the radius squared. Now I just got to do some algebra. Let's divide both sides by pi, right? This is me again doing reverse BADMAS because I want to get the r all alone. I want to know what the radius is. All right, so here I'm going to divide this side by pi. I'm going to divide this side by pi. And that means that these two cancel out to leave me r squared. And 552.67 divided by pi gives me 175.92. Make sure you can see this. R squared equals 175.92. Okay, if I know what r squared is and I want to find out what just plain old r is, that means I got to square root both sides. Square rooting this side over here will give me r. And if I square root the other side, 175.92, I get 13.26. So that means my radius is 13.26 centimeters. Phew, all that just to get to the radius. Great. If I've got the radius and I've got the central angle, then suddenly this job of finding the arc length isn't so difficult, right? Let me go over this formula here. I've got the radius and I want to find circumference. This has been a while, but the formula for getting the circumference, if I didn't know the area, let me write that up here in case you've forgotten it, is equal to 2 times pi times the radius. That's how you get the circumference if you know the radius. So that means I can get the circumference here by plugging in the number that I know, which is the radius, 13.26. Ran out of space there. Circumference equals to 2 times pi times the radius that I got. So that radius times 2 times pi gives me my circumference, 83.34. Circumference is 83.34 centimeters. Now that I know that, I can put that right in here, right? If I know that the circumference is 83.34, then I can already write that arc over this circumference equals to the central angle, which I know from back here, over 360. Okay. Arc over the circumference equals central angle over 360. Now, to get arc, what do I have to do? If I've got this all set up, only one thing, got to do the fish method, right? 83.34 times 108 divided by 360. Let's do that. The arc is equal to 83.34, that's my circumference, times 108 divided by 360. And then I get out my calculator. Again, it still knows the actual circumference, not rounded to any decimal places. I multiply that by 108. I divide it by 360. And it gives me my final answer. 25.001, which I can round to the closest hundredth, is 25.00. So I can just write 25. And that means that the arc is going to be 25 centimeters, like that. Okay, so a quick recap. We drew the diagram, important first step, so I could keep track of what I was doing. Then I put the information I knew into the diagram. The sector area is 165, the central angle is 108. I used that and this formula by plugging in the 165.8 into the sector spot, the 108 into the central angle spot, and that got me the area. Once I had the area, I knew that I could use area equals pi r squared to solve backwards and figure out what the radius was. With the radius, I knew I could use the radius to get the circumference, because circumference equals 2 times pi times r. And when I had the circumference, which went in the circumference spot, and the central angle, which went in the central angle spot, now all I had to do was fish method to get the arc, which was 25 centimeters.